going to learn the systematic approach of naming organic compounds. And to do that, we're going to use the example of alkanes because it's the easiest. And from here on out, as we learn about different functional groups, at that point we will learn how to name those. But for now, we'll only think about naming alkanes. First off, we'll need to learn about naming straight chain alkanes. Alkanes that have no branches, just a straight chain of carbons. For methane, it's 1 carbon. For 2 carbons, it's ethane. 3 carbons, propane. 4 carbons, butane. 5 carbons, pentane. Hexane, heptane, octane, etc. This is just 1 carbon, nothing but hydrogens bonded to it, then 2 carbons bonded to each other. The rest are hydrogens. 3 carbons bonded to each other in a row, then hydrogens, so on. But as we get into things that are more complicated, that branch off, it becomes difficult to name these things, and that's what the systematic approach is for. Something like this, it's not obvious what we should call this. If we should just count the carbons and then call it that, but then of course there are a whole bunch of different ways this thing can be arranged. So that is the point of the systematic approach. So we'll begin with the first step, which is to find the longest carbon chain. And there's also a side note, really, which should be included in the second step, but in this example that is selected is a bit of an exception because there are 2 chains that are of equal length. So we need a first step is to find the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 7 this way. But it doesn't really matter which way this one goes, it'll look the same. So it could go this way, or this way. And normally the second step would be to number the carbon chain, starting with n nearest a branch. But when there's a tie like this, there's 1, 2, 3, 4, both of them have 7. 2 are of equal, start with the nearest substituent, which is the same thing as a branch. So I just put that on there just to clear up any confusion, because once we learn how to do these, it's very, very easy. So if there's a tie, we gotta use the one that has the nearest branch. So 1, 2, 3, it takes 3 from this end, 1, 2, 3, 3 from this end for the red one. Now for the green one, 1, 2, 3, 1, 2. So this one on this end down here, there is a branch on the second carbon. So we're going to use this green one. So I'm going to highlight this main chain. I didn't mean to do that. It doesn't matter if it's this one or this one. It's going to end up the same thing. It's going to end up on the second carbon. I'm just going to use this one. So this is the main chain. Number the chain, starting the end nearest a branch. So this is the nearest branch. So I'm going to number this 1, 2, 3, 4, 5, 6, 7. So I've numbered all the carbons. Now I continue on to the next step. Name the substituents and give location on the main chain. The substituents is another name for the branches. So here's a branch, and here are the names of the branches. Since they're all alkanes, it's easy. Basically, since these are smaller straight chain alkanes, I would use these names: methane, ethane, propane, butane, hexane, depending on how long those little branches are. But instead of using that, I'm going to call them methyl, ethyl, propyl. This YL signifies that it's a branch. So I'm going to name all of these little groups. So this is methyl, ethyl, another methyl, and one more methyl. And then this is on the second carbon, this is on the fourth carbon, This is on the third carbon. This is on the fifth carbon. You can do this however you want. I mean, normally I just do this in my head. But we're just diagramming it for simplicity's sake. Name system, give the location on the main chain. When two or more substituents are present, name in alphabetical order. When two or more of the same are present, then use die, try, etc. So this is how we're going to name it. So the main chain, 1, 2, 3, 4, 5, 6, 7. So it's going to be a heptane. But we've got to name all these substituents as well, and branches. We've got 1, 2, 3 methyls. 3 methyl groups, 1 ethyl group, and this is on a heptane. So we're going to go in alphabetical order, and the way to do this is to lead with the location of the first group, which is going to be the ethyl group because it starts with an E. So it's on the third carbon, so I'm going to say 3 ethyl, and then next methyl, because it's an M. But there are 3, so it's going to be tri. Here it says use die, try, etc. for however many there are. So there are 3 methyls, so it'll be, I got to name the locations of them. 2, which one says 4, 5. 2, 4, 5. Try methyl. I should put a dash there. Trimethylheptane. Some of these can be really long, and especially once you get into stuff with a lot of branches and there's a whole bunch of other crap in there, then it can sometimes be a real pain sometimes. But this is the basic approach for naming things systematically, and then once we learn about different functional groups, they're going to have different little names. Instead of propyl, there's going to be ene, and then obviously for alcohol you add all on it. So there are going to be a whole lot of different little things that we'll learn as needed when we learn the different functional groups, but they're all going to follow this basic format. Find the longest continuous chain of carbons, number the chain starting with the end nearest branch, name the substituents, give the locations on the main chain, and then when there are 2 or more substituents, name them in alphabetical order, use die, try, etc. to elaborate on the name.